Welcome to chemistry classes. In this video we are going to discuss about naming of elements, its atomic number greater than 100. Naming of elements, its atomic number greater than 100. Also we will discuss in this video electronic configuration, subshell electronic configuration and the periodic table. Okay, so here first we have to check here nomenclature of elements, its atomic number greater than 100. Okay, so here after discovery of a new element, IUPAC gave a temporary name. Okay, we are going to discuss about how to give this temporary name. Okay, and here this temporary name depends on the atomic number. After discovery of a new element, IUPAC gave a temporary name. There is a IUPAC system to give a temporary name. Okay, so we are going to discuss how to give this name. Okay, so here the name is depends on the atomic number. Okay, and also some numerical roots are used. Numerical roots mean here we will use some prefix. Here 0 for 0 we will use nil, 1 we will use un, 2 by, 3 try, 4 code, 5 pent, 6 hex, 7 sept, okay, 8 oct, 9 n. Okay, so here something you learned before in organic chemistry. It is similar but all not similar. There are some difference. Okay, so you can check here difference: 0 nil, 1 un, 2 by, 3 try, 4 code, 4 not tetra, here it is code. Okay, 5 pent, 6 hex, 7 sept, not x, sept, oct, here n, not here 9 n. Okay, so this type of prefix we used. Okay, so how to use this prefix to give IUPAC name for a new element? Imagine one element with atomic number 101. So 101, 1 mean it is un. 1 mean un. Okay, so we will use un. 0 it is nil. Okay, un nil, again 1, un nil un. So look here, un nil un. At the end we have to add ium. All case at the end we have to add ium. Okay, so its name will be unulinium. Okay, and you can use its symbols for this element: nil n, un u, by b. You can use this for symbol. So here un u, nil n, again un u. So this will be symbol. See here another example: IUPAC name for the element, its atomic number 105. So we can use again here 1, un, nil. Here 5 mean it is pent. Okay, un nil pentium, So you can use the first letter for the symbol UNP. First letter use capital letter. First letter, capital letter. Okay, you can use symbols like this. Last example here 107. So here un nil sept, 7 means sept. Okay, un nil septium, Okay, so here symbol UNS, sept, symbol S. Okay, so here you have to remember this different numbers and their symbols Okay, this is called numerical roots. So you have to remember numerical roots for 0 and 1 to 9. 0 to 9 you have to remember their numerical roots. Then you can name and you can find the symbols of this elements. Its atomic number greater than 100. Okay, next one we have to discuss here subshell electronic configuration and periodic table. Subshell electronic configuration and periodic table. We know subshell electronic configuration. Subshell electronic configuration. Here subshells are arranged according to their energy. 1s, 2s, 2p, 3s, 3p, 4s, etc. Look here, we have different type of subshell electronic configuration. 1s, 2s, 2p, 3s, 3p, 4s, 3p, 4s. Up to calcium we will do like this: 3s, 3p, 4s. Okay, 3s, 3p, 4s. Okay, but after scandium there will be another orbital. 3d orbital is coming. Okay, 3d orbital after calcium. Okay, here till 20 elements, 20 atomic number, we have to follow this one. Okay, after atomic number 20 we will follow this one. Okay, 1s, 2s, 2p, 3s, 3p, 3d, 4s. Here 4s orbital fill first before 3d. We will write like this: 3p, 3d, 4s. Okay, but here electrons are filled 4s before 3d. Clear? This will follow scandium to zinc. Scandium, this one follow after scandium, titanium, vanadium, chromium, manganese, iron, nickel, chromium, zinc. Okay, so this method will follow from scandium to zinc. Clear? Here 1s1. Here this 1 represent principal energy shell. Principal energy shell or principal quantum number. Here 1s1. Here n is equal to 1. We know there are 4 different type of quantum number. Okay, principal quantum number. Here 1 represent principal quantum number. We know nucleus. An atom consists of nucleus. Around nucleus there are many energy level. These energy levels are called principal energy level or main shell. Main energy level, main shell or orbit or principal energy level. You can say like this. So here 1s1, one atom, its outer shell electronic configuration. 1s1 mean this atom in first here 1s1 mean this electron in first energy level. 3d6 here n is equal to 3. 3d6 here n is equal to 3. So this electrons will be in third orbit. It will be in third orbit. Okay, so here n represent principal energy level. These are principal energy level. Each principal energy level there are subshells. These subshells are represented by SPDF. Subshells are represented by SPDF. Okay, each subshells consist of different number of orbitals. Okay, each subshells consist of different number of orbital. S subshell consists of 1 orbital, P 3 orbital, D subshell consists of 5 orbitals, F subshell consists of 7 orbital. Okay, so main energy shell, subshell, each subshell consists of different number of orbitals. S 1, P 3, D 5, F 7 orbitals. Clear? Okay, next one we have to discuss here subshell electronic configuration and period. Relation between period and subshell electronic configuration. Outer shell electronic configuration. Outer shell electronic configuration help us to predict number of period of an element. Okay, so here the value n value of outer shell electronic configuration shows number of period. N value of outer shell electronic configuration. It's mean we know first period there are two elements, hydrogen and helium. Hydrogen atomic number 1s1, 1s1. So here n is equal to 1. So it will be first period. Here n is 1. N value 1. So it will be first period. Helium atomic number 2, 1s2. Also here n is equal to 1. So here helium also first period. Clear? Next one, see here, when you check second period, there will be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so here all this case, here lithium atomic number 3, 1s2, 2s1. So here n is equal to 2. Okay, beryllium atomic number 4, 1s2, 2s2, n is equal to 2. So here n value 2. Okay, you can check all here outer shell electronic configuration 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. So all case n value 2. So all these are second period. Clearly, when you check third period elements starting from sodium to argon, you can check outer shell electronic configuration and you can understand all these elements are in third period. Clear? Also we discussed before the subshell electronic configuration difference. Okay, I told you before up to calcium this is the order 1s2, 2s2, 2p6, 3s2, 3p4s. Up to calcium this is the order of subshell electronic configuration. There is some slight variation in subshell energy. Okay, in after calcium there is some slight variation in the energy level. That's why we will arrange electron a different way. Clear? So here look here 1s2, 2s2, 2p6, 3s2, 3p4s. Okay, so here outer shell 4. Okay, so also here calcium here it will be 4s2, 1s2, 2s2, 2p6, 3s2, 3p6, after 3p6 4s2. Clear? So here third period it will be sodium to argon and these elements potassium and calciums are coming in fourth period. That's why here outer shell configuration 4s1 here, fourth period, outer shell configuration 4s2 here. So here it will be fourth period. Clear? So when you check this one, transition elements, you can check here periodic table. Transition elements are between S block and P block. Okay, there are 3 transition series. Okay, you can check in this periodic table. In transition elements there are 3 period in transition elements: scandium to zinc, ytterbium to cadmium, lanthanum to mercury. These are the 3 series, 3 period in transition elements. Okay, so here scandium to zinc 3d4s, outer shell electron configuration will be 3d4s. First period in transition elements 3d4s. Okay, so outer shell electronic configuration 3d4s. That's why these elements are called 3d transition series. 3d transition series because outer shell electrons are 3d4s. That's why it is called 3d transition series. Okay, ytterbium to cadmium 45s. You have to add 1 here, 4d5s. That's why here outer shell electron configuration 4d. That's why these elements are called 4d transition series. 4d transition series. Clear? After that, when you check next period in transition elements, lanthanum to mercury 5d6s, outer shell electron configuration 5d6s. That's why these elements are called 5d series. So there are 3 series in transition elements: 3d series, 4d series, 5d series. 3d mean scandium to zinc, 4d mean ytterbium to cadmium, 5d mean lanthanum to mercury. Okay, so you remember this elements and series. 3D series scandium zinc, 4D series ytterbium cadmium, 5D series lanthanum mercury. Clear? Okay, next one here we have to discuss here 6th and 7th period. 6th and 7th periods are coming in F block elements. F block elements. Okay, so see here 6th period in periodic table. You can check here. You can see here there are 32 elements in 6th period. 6th period there are 32 elements, and here 6th period, so n is equal to 6 outer shell electronic configuration. Okay, look here, this is outer shell electronic configuration. Here n is equal to 6. Clear? And this is outer shell electronic configuration 4 of 5d6s. 4 of 5d6s. That's why here these elements are called 4 of inner transition series. Before we discuss in D block elements, we discussed 3D series, 4D series, 5D series according to their outer shell electronic configuration. Here we have 6th and 7th period. 6th period outer shell electronic configuration 4 of 5d6s. 7th period their outer shell electron configuration, you have to add one more, 5 of 6d7s. Look here, 5 of 6d7s. This is the outer shell electronic configuration for 7th period. Okay, so here this is 6th period. 6th period, it consists of 32 elements, and this is outer shell electronic configuration 4 of 5d6s. 4 of 5d6s. Also you can remember very easily 4 5 6. Okay, FDS. Okay, 4 of 5d6s. Also here 5 6 7. 5 of 6d7s. Here 4 of, that's why this is called 4 of inner transition. 4 of inner transition series. Before we discuss transition series, but 6th and 7th period, these elements are called inner transition series. The previous one transition series, this one inner transition series, 4 of inner transition series. Also these elements are called lanthanoid series. Lanthanoid series. Okay, lanthanoid series. These elements starting from cerium to lutetium. So remember all these things. 4 of inner transition series starting from cerium to lutetium. Okay, and outer shell electronic configuration 4 of 5d6s. Clear? 7th period here n is equal to 7. 7th period n is equal to 7. Outer shell electronic configuration 5 of 6d7s. 5 of 6d7s. That's why these elements are called 5 of inner transition series. 5 of inner transition series. These elements also called actinoid. These elements are called actinoid. Actinoids are starting from thorium to lawrencium. The first one cerium to lutetium. Cerium to lutetium. Here thorium to lawrencium. Okay, so remember these things related to 6th period and 7th period. Clear? Next one we have to discuss here group wise electronic configuration. First we discuss electronic configuration and period. Next one we have to discuss here subshell electronic configuration and group wise electronic configuration. Elements which coming in same vertical column means same group. They have similar physical and chemical properties. Example here group 1 elements lithium, sodium, potassium, rubidium, cesium, francium. These are group 1 elements. Okay, these elements shows similar physical and chemical properties. They are highly reactive. Even they react with cold water. Okay, also these metals, these elements are gray color. They are soft metals. Okay, so these elements show similar physical and chemical properties. So elements which coming similar or same vertical column or group showing similar physical and chemical properties. Okay, next one we have to discuss here electronic configuration and the type of elements. Electronic configuration Based on this electronic configuration, we can classify different type of elements: S block elements, P block elements, S, P, D and F block elements. Okay, before I told you P block elements and F block elements, how this block coming, this is we explaining here. Okay, S, P, D and F block elements. This classification of elements are classified S block elements, S, P, D and F block elements. This classification depends on outer shell electronic configuration. This is also depends on the electronic configuration, outer shell electronic configuration. Okay, but there are two exception case. In here. In this concept, there are two exception case: hydrogen and helium. Helium, we know, 2 electron, it is 1s2. Okay, in periodic table, okay, you can check here. This is periodic table. Here in periodic table, it is you can see here there is S block elements, P block elements and D and the F block elements. Okay, S, P, D and F block elements. Okay, so here helium, it is 2 electron, atomic number of helium 2, 1s2. So actually based on outer shell electron configuration, it must be in S block, but here helium included in P block element with group 18, because helium, neon, argon, krypton, xenon, this element, they have similar properties. That's why helium put in P block element with group 18, not in S block element. So this is one exception case. Second exception case, hydrogen. Hydrogen atomic number 1s1. That's why hydrogen put in S block element. But hydrogen also receive 1 electron and it will show negatively charged -1 charge. Okay, lithium hydride. Okay, metallic hydride. Sorry, metallic hydride. In metallic hydride, hydrogen receive 1 electron and it shows negative charge. We know group 17 elements: fluorine, chlorine, bromine, iodine. These elements receive 1 electron and shows -1 charge, -1 charge. Okay, so here actually hydrogen in S block element, but it also showing some characters of group 17 elements. Okay, so there are two exception case in this concept, hydrogen and helium. Rest of them based on subshell electronic configuration, we can classify S, P and D block elements. Clear? Okay, next one we have to discuss here S block elements. Classification of elements S, P, D and F. First one we have to discuss here S block elements. S block elements mean in periodic table group 1 and group 2 elements together called S block element. Group 1, group 2. Group 1 elements also called alkali metals. Group 1 elements are called alkali metals. All group 1 elements, their outer shell electronic configuration S1, NS1. First period 1s1, second period 2s1. Okay, so outer shell electronic configuration, it will be NS1 configuration. Second group elements are called alkaline earth metals. Its outer shell electron configuration coming NS2. Okay, and here group 1 S block elements are compared to other metals. S block elements are highly reactive. Even they react with water. They are soft metal. They are gray color. They do not make colored compounds. S block elements. Okay, and they have low ionization enthalpy. These elements, S block elements, they have low ionization enthalpy comparatively. Okay, and they have strong tendency to lose electron. After losing electron, they form positively charged ion. Group 1 elements in periodic table, S block elements mean group 1 and group 2. Group 1 elements lose 1 electron and form +1 positively charged ion. Example, Na plus, Li plus. Okay, group 1 elements, they have outer shell 1 electron, they lose 1 electron and form plus 1 charge, positively charged ion, plus 1 charge. Similarly, group 2 elements, they have 2 outer shell electron, they lose 2 electron and form plus 2 charge, positively charged 2. Example, magnesium 282, magnesium outer shell 2 electron, they lose 2 electron. Calcium group 2, they lose 2 electron and form Ca2 plus. Okay, magnesium Mg2 plus. Sodium, lithium group 1, Na plus, Li plus. Okay, so here group 1 and group 2 together, S block elements, the compound of S block elements are generally ionic character. Compounds of S block elements generally ionic character, except lithium and beryllium. Lithium and beryllium also showing covalent character. Okay, so other compounds of S block elements are ionic character. Clear? Okay, next one we have to discuss here P block elements. P block elements mean group 13 to group 18. These are P block elements. Okay, and outer shell electron configuration ns2 np1 to ns2 np6. Okay, group 13 to group 18. So here group 13, its outer shell electron configuration ns2 np1, then ns2 np2, ns2 np3, then it will end in group 18 ns2 np6. This is outer shell electronic configuration. P block elements starting from group 13 to group 18. S and P block elements together we will say representative elements or main group elements. In periodic table, S and P block elements together we will say representative elements or main group element. Clear? This is subshell electronic configuration. Here in P block elements, group 18 elements are called noble gases. Group 18 in periodic table, group 18 called noble gases or inert gases. Okay, helium, neon, argon, krypton, xenon, these are the elements which coming in group 18. These elements are called noble gases or inert gases. They have complete outer shell electron configuration ns2 np6. Their electron configuration complete. Okay, they have complete electronic configuration. That's why these elements do not lose or gain electron. Okay, that's why these elements do not involve, generally these elements do not involve any type of chemical reaction, but there are some exception case you will study in grade 12. Okay, so here generally we can say noble gases, they do not involve any type of chemical reaction. Okay, that's why these gases also called inert gases. Clear? And here another one, halogen. In P block elements, group 17 elements are called halogen. This is group 18. Group 17 elements are called halogen. Okay, they have outer shell electron configuration ns2 np5. This is halogen. Fluorine, chlorine, bromine, iodine, astatine, these are the elements which coming in group 17 halogen ns2 np5. Clear? Next one, group 16 elements. Group 16 elements also called chalcogen, oxygen. Okay, oxygen, sulfur, selenium, tellurium, polonium, these are the elements which coming in group 16. Okay, they have outer shell electron configuration ns2 np4, chalcogen. Clear? Here group 16 and group 17, they have high negative electron gain enthalpy. Group in periodic table, group 17 and group 16. In periodic table, group 16, group 17 elements have high negative electron gain enthalpy. Okay. Also, when you are moving from left to right in periodic table, the left part of periodic table it is metal, right side it is non-metal. S block D block, these are metals. But when you are going to P block, it is non-metal. So when you are moving from left to right across the period, metallic character increases. Metallic character increases. Clear? Okay, next one we have to discuss here, D block elements. D block elements also called transition elements. Transition elements. Group 3 to group 12 elements are transition elements. In periodic table, group 3 to group 12 elements are transition elements, okay, or D block elements. They have outer shell electronic configuration NDNS, okay. They have outer shell electronic configuration N-1D, N-1D, 1 to 10 electron, then NS 1 to 2 electron. These are the general electronic configuration of D block elements. N-1 D 1 to 10 electron, NS 0 to 2 electron, depends on each element, okay. So here N will change, maybe 1 to 10 electron possible, okay, and here it will be N, and here S orbital 0 or 1 or 2, okay. These are the possible electron or outer shell electron configuration. Next one, we have to understand here properties of D block elements. Properties of D block elements. We know D block elements, most of the D block elements are metals. They are good conductor of electricity. They are malleable and ductile. Malleable and ductile. Malleable mean we can change metal to metal sheet by applying high force. That is malleable. Also metal can change to thin wire, metallic wire, by applying force. That is ductile. So metals are malleable and ductile. D block elements, most of the D block elements are malleable and ductile. They are good conductor of electricity and heat. And D block elements make colored compound. Generally D block elements are colorless, but they make colored compound. Example, copper sulfate, blue color, potassium dichromate, orange color, potassium permanganate, purple color. They make manganese, potassium permanganate, manganese there, potassium dichromate, chromium there. These are D block elements and they make colored compound. Okay, so here properties of D block elements, they make colored compound, and here D block elements, they have variable oxidation state. They have multiple oxidation state. For example, iron Fe2 plus, iron Fe3 plus. Okay, so also copper +1 +2, cobalt +2 +3. So here D block elements shows variable oxidation state. Okay. And we discussed D block elements, they are malleable and ductile, they are good conductor of electricity and heat. And D block elements or D block compound used as catalyst. For example, Haber process means production of ammonia, iron used as catalyst, iron transition metal, D block element. Vanadium compound V2O5 used as a catalyst in contact process. Contact process means production of sulfuric acid. Okay, so here D block elements or compounds of D block elements used as catalyst. So these are the properties of D block elements. Clear? So here you have to understand zinc, cadmium, mercury. Zinc, cadmium, mercury, they do not show D block elements. They do not show properties of D block elements because zinc, cadmium, mercury, they have complete outer shell electron configuration. Here D, there is 10 electron. S orbital, there is 2 electron. Okay, zinc, cadmium, mercury, they do not show, they are in D block elements, but they are not showing D properties of D block elements because they have complete electronic configuration. Okay, so these are the things we have to understand about D block elements. Okay, next one here, last point in this video, we have to discuss here F block elements. F block elements. F block elements mean sixth and seventh period elements together called F block elements. Okay, sixth and seventh period elements together called F block elements. F block elements also called inner transition elements. F block elements also called inner transition elements. Okay, F block, D block elements, transition elements, F block elements, inner transition elements. Also, F block elements consist of lanthanoids and actinoids. Lanthanoids means sixth period elements are lanthanoids, seventh period elements are actinoids. Okay, and these are the general outer shell electronic configuration of F block elements. N-2 F 1 to 14, N-1 D 0 to 1, not 0 to 10. Remember here 0 to 1, 0 or 1 electron. There is no electron up to 10. So you have to remember outer shell electronic configuration N-2. Here look N-1, N-2. SDF, N-1, N-2. Here 2 electron, here 0 to 1 electron, 1 to 14 electron. This is outer shell electronic configuration of F orbital. F block elements. F block elements means F block elements, all F block elements are metals. Okay, and F block elements mean we discuss lanthanoid and actinoid. Here actinoids are radioactive elements. Actinoids are radioactive elements. Elements coming after uranium, it is called transuranium. Okay, transuranium elements mean elements coming after uranium. They are transuranium elements. Okay, so here these are the things we have to discuss in this video. You can review the video once again. Okay, so thank you for watching this channel.